What's up? What up? Let's give differentiation a go. This is calculus differentiation, the same thing. This is a very basic test, right? We'll go through all the questions here. This will get you sharp. This is differentiation or calculus 101. Let's go. Find the first derivative with respect to x of the following when x is equal to 3. Grand. You're just bringing it, so like x is equal to x squared plus 5x minus 8, and all you have to do, minus 5x plus minus 8, all you gotta do then is just bring it to the front. Oh my god, my writing all over the place. Check this out. You're gonna bring the 2 to the front. That's all you do. So this becomes 2x. When you differentiate, it becomes 2x. The power is still 1. When you're differentiating 5x, it just becomes plus 5. Okay, that's all. And the 8's gone. It's a squiggly, the squiggly 8 here is gone. That's what happens when you differentiate it. F dash x, as I often say, f dash x. That's what you mean by differentiation. F dash x differentiation is equal to that, and all you got to do then is sub in when x is equal to 3. So it's pretty easy from there. Then you just got to sub in. So sub in for x is equal to when x is equal to 3. So 3 in for here becomes 2 bracket 3 plus 5, and that gives you 6 plus 5 is 6 plus, so when x is equal to 3. Oh, this wasn't fully finished. The answer here will be, I'll show you this. The answer here should be 11 when you get this out. I'll tweak the form. It'll be 11. Next, find the minimum of the function given by minimum. Okay, given by this. So dy dx. So you're essentially what they say minimum, max, and min. You're gonna put f dash x, so the differentiation part of it, put equal to 0, and you solve it. I'll say that again. If you're looking for the minimum, just differentiate it, put equal to 0, and solve it. When they're looking for the minimum or the max, differentiate it, put equal to 0, and solve it. So differentiate this one here. So you're going to bring the 2, watch my screen, you're going to bring the 2 up in front, so it becomes 2 by 2, which gives me 4. So 2x squared, when I differentiate 2x squared, it becomes 4x. Does that make sense? Because you bring the 2 front, that should be easy. Differentiate this one here. What's minus 4x? Differentiate, it's just minus 4, guys. And the 2's gone. And so put that equal to 0. And so finish it off. 4x is equal to, bring the 4 over. Right? That becomes plus 4. And so, sorry, you want to differentiate it. So you probably differentiate, well, you can do from here. So you can just, so x is equal to what? X is equal to 1, right? X is equal to 1. Obviously, x is equal to 1, and then you sub that back into the original. Sub that back into the original, which is up here. Sub in 1, what are you going to get? 2 by x squared is 2 minus 4, so 2 minus 4 plus 2. So it ends up being 2 minus 4 plus 2, which works out perfectly as 0. So your answer is 1, 0. Does that make sense? Does that make sense? So like you just, when you're asked for max and min, you just have to put the differentiate it and put equal to 0. You solve it, which is what we did there. And when you have the x1, you sub back into the original to find y. Because then look, this is our x1, which is 1. And I sub it back in here, sub your 1 back in here for x, you're going to get 0. Makes sense. And that's why we end up this answer here. Super. The distance traveled by an object is given by the following function. I just look wordy, it looks messy, but if you're doing Leaving Cert, this is going to be like in section A and section B of paper 1. The distance traveled by an object is given by the following function, respective time for t is greater than 0. St, so all looks messy. But look, st and xt, like, look, you just write out what you got. Write out what you got, which is t, 2 t cubed, right? That's what you have there. Get rid of that t there. Not needed. Minus 6 squared plus 2t plus 5. All right. So you have that, and what is the speed after 3 seconds? And you can find the speed, so differentiate to find the speed. So look, differentiate this, you're going to bring the 3 in front, and 3 by 2 gives me 6, so it becomes 6t squared. Remember, it goes down 1 as I often think. So instead of 3, it becomes 6t squared, right? Minus, you're going to bring the 2 in front, I often say, minus 12t. Yeah? Does that make sense? Plus 2 plus 2. That's what is differentiated. All right, that's what it is differentiated. Is that okay? You got that? That's what is differentiated. And what is the speed after 3 seconds? So you just sub in for 3, the time. Sub in for 3. So when t is equal to 3, you're going to sub in with t is equal to 3. You can get that. So it becomes 6 by 3 squared. 3 squared is 9. Heads up. Minus 12 by 3. You're just subbing in then. This is easy. Plus 2. Like that far. If you're following along that far, you'll find out that, oh, differentiate and then just sub in. That's all I did. Minus 12t plus 2. That's what we had when we differentiated, right? Remember, we just differentiated. That's what I had when we differentiated. So find the time where the velocity is 2. So speed or velocity, same thing. Just put it equal to 2. And does not work out here. Simple. Do these not cancel off? So you can, if you differentiate 6t squared, how would you factorize in? Because you got 6t squared minus 12t is equal to 0. And this is a bit of a hard one for level, but you'd have to factorize that. So what's common there between two of them? 6t. And that leaves you with t minus 2 is equal to 0. You can then finish off by factorizing. So either 6t is equal to 0, or you'd have t minus 2 is equal to 0. And you're going to finish it off here. T is equal to what? Plus 2. Could you bring this over? So it becomes plus 2. That's your answer here. And this one here is 6t is not, so like remember it says here t is not equal to 0. So that means this one is useless for you. And so the answer is plus 2. Make sense? Cool. The distance traveled by an object is given by the following function with respect to time for t is the same thing. Find the acceleration after one. Acceleration, double differentiate. So just acceleration, think double differentiate. Does that make sense? Acceleration, think double differentiate. So this is like the first differentiate, and if you did double, it's not actually, yeah, well, same thing. If you did double differentiate, this one, so if you to differentiate this one here again, 6t squared minus 12t, and there's a 2 there, but it doesn't matter, this, minus 12t. If you double differentiate this, what are you going to get? You're going to bring the 2 in front, and so this becomes just 12t minus 12, and find the acceleration of the object after 1 second. And once you believe this, you're going to sub in 1 for t, so t is equal to 1. So you're actually going to get the answer to be 0, lads. Because by the time you sub in t for 1, stuff goes in here, so 12, take 12 is 0. That's it. Is the 6th question? There's not. That's it. Funny one. But yeah, that's it. That's differentiation. Like, to me, it's just like you're just like you're differentiating and then you're solving. Differentiate, solving. It follows pretty much the same patterns every